Okay, I wanted to walk through some of the theory and some of the terminology. Unit 10 Lab 2 transistors. So taking a look at this basic circuit, what we have is an 8-volt source here and a 12-volt source here. And this voltage could be quite a bit higher, but we're just using it because that's the voltage rating for the lamp. So this is the lamp right here. This is the transistor, and the terminals are the base, the collector, and the emitter. And then we have a resistor on the input going into the base, which limits the current, a switch that is basically turning the circuit on and off. So let's take a look at this and see if we can make some, kind of do a little bit of analysis with it. So if the switch is open, we would not expect any current to be flowing between these 2 points here, which would mean we'd have no current flowing into the resistor and no current flowing into the transistor itself. In that case, in this circuit, this transistor is turned off, which essentially means that it is completely disconnecting or opening up the output here from the collector and allowing no current to flow through the whole device. So that is in the off state, and we can use that to turn the output off. However, if we close this switch, it now allows current to flow into the base through this resistor here, and that allows this large current to flow into the collector. And since the lamp is connected between the power supply, the positive 12 volt, and the ground, what happens is we end up getting a small voltage drop here, maybe around 0.1 or 0.2 volts between the collector and the emitter, but all the rest of that voltage now is across the lamp, and that allows it to light up. So a couple of things that in the lab, as you'll be going through, that are important to understand. If we take a look at the left side of the circuit, the current flowing into the base, in this case, which is called I sub B, is the same as that current flowing through the resistor. We could call it I sub R1. Those are the same currents because current is flowing into the circuit. For the collector current, the current flowing through into the lamp, which I call I lamp, is the same as the current flowing into the collector, which is called I sub C. So it's important to understand those terms mean the same thing. IR1 is the same thing as I sub B, the current flowing into the base. And I lamp, the current flowing into the lamp, is the same as the current flowing into the collector, which is called I sub C. Now the emitter is connected to ground, and ultimately what it does is it sums this base current with the collector current. But because the base current is so small by comparison, only a few milliamps compared to as much as many amps of current, it ends up being mostly the same as the collector current, but it's connected to ground. Now let's take a look at the voltages. We already mentioned that VCE, which is the voltage across the collector and the emitter, is very small, typically something like 0.2 volts when the transistor is turned on. When the transistor is conducting, though, we also have a voltage drop between the base and the emitter, which is called VBE. Now, for regular transistors like this transistor here, VBE might be on the order of like 0.6 or maybe 0.7 volts. That's typical. What's interesting, in the lab, we're actually using a circuit that uses what is called a Darlington transistor, which essentially connects 2 transistors together like this. Now, you might think, why would you want to do that? What's the advantage? Well, it turns out that the beta or the current gain of each of these transistors is amplified by the other beta, so you get these huge gains on the order of tens or hundreds of thousands. So that's one advantage. But what's interesting, though, is that because of the way that the circuit is arranged, the VBE ends up being a lot larger, so it's more like 1.4 volts. So If we take a look at, for example, let's say we're trying to measure our VBE, how would we do that? Well, on our transistor, looks something like this. We have our base, collector, and emitter. If we wanted to measure the voltage across the base and the emitter, we simply measure the voltage on those pins on the transistor, the base and the emitter. Now, if the transistor is off, we'd expect that to be 0, but if the transistor is turned on, we'd see that voltage drop. If we're trying to measure VCE, the voltage across, in this case, we can kind of look at it like this, the voltage between the collector and the emitter. Now we'd use the meter and measure between these two pins. Now you have to be careful when making these measurements because if those pins short out, you could damage the transistor or damage the circuit. So you have to be careful when you're doing that. The other voltage measurements, if we're trying to just measure the voltage across the lamp, we simply measure between those 2 points there. If we're trying to measure the voltage across this resistor, we measure the voltage across these 2 points. If we're trying to measure across the switch, again, we measure across the switch for voltage. In this lab, you will not be using the meter to measure current the way we have in the past. We're going to be using some calculated values or looking at the power supply to actually see those. So that's in the lab video.